Okay, daily task number 4. You are faced with a table that looks like this, and you've been asked to describe the atomic number and what information it gives us, and the mass number and what information it gives us, which leads us nicely into a task which allows us to use that information to complete. Now, if you remember from a previous task, we had a look at this. So using carbon, again as the example, the periodic table shows us this symbol and 2 numbers associated with it. Okay, it's the same for every element on the periodic table. They've all got their own unique mass number and atomic number, 2 different numbers associated with each element. For carbon, it is 12 and 6. And carbon has the number 12, which is its mass number. And the mass number tells us the number of protons and neutrons. Okay, so this is going to be the description. Okay, the mass number gives us the number of protons and the number of neutrons. Okay, the atomic number is the smaller number because it's only dealing with one type of subatomic particle. And in this case, it is the number of protons. Okay, if we look at our table, we're asked to find the number of protons, electrons, and neutrons. Okay, so electrons. Okay, previous daily task, we look at this in more detail, and we have found that with an atom, that the number of protons and electrons are equal, because an atom is a neutral substance. It has absolutely no charge whatsoever, which means that the positive protons must equal the number of negative electrons to cancel out the charges. Okay, if there's one positive for every negative, they cancel each other out, 0 charge. Okay, so we can assume that in this case, we are looking at an atom that has no charge. And if an atom has no charge, it must then mean that the protons are equal, it's not the best, is it, to electrons. So that helps us to work that out. The other thing we need to know is to calculate the number of neutrons. Okay, because the atomic number gives us the number of protons. If it's an atom and there's no charge, the number of protons we can find from the atomic number is going to be the same as the number of electrons. But our neutrons are muddled up with the protons within the mass number. But if we know the number of protons here, we can take that number away from that number. It leaves us with the number of neutrons. Okay, so we need to do a little calculation. The first step to answering this is we need a periodic table, and we need to find the atomic number and the mass number for each of these elements. Now C, H, E, L, I, B, E and B can all be found on the periodic table. Carbon is done for us as our example. Helium is He. Now helium, the bigger number, the mass number is a 4. That's already there. Good, we're on the right track. The atomic number is the other number, the smaller one. We can put a number 2 in there. That's the atomic number of helium. Let's fill all these in first. So let's look at lithium next. So lithium here, it has a number 7 and a number 3 associated with it. The larger of the 2 numbers is the mass number, number 7, and the smaller of the 2 numbers is a 3. That's our atomic number. Okay, beryllium, right next to lithium, it has a big number of 9 and a little number of 4. Okay, 9 and a 4. The larger number is our mass number, and our smaller number is our atomic number. Again, because the mass number is incorporating 2 lots of subatomic particles, protons and neutrons. It's going to be a bigger number. And finally, boron. has the numbers 11 and 5 associated with it. Okay, so our mass number is the bigger one of 11 and our atomic number is 5. Straight away, we know that our atomic number is the number of protons. So for each of these, we can use our atomic number to complete this. Carbon, our example, atomic number is 6, protons is 6. Helium, atomic number is the number of protons, 2. Lithium, atomic number 3, therefore the number of protons is 3. Atomic number for beryllium is 4, number of protons is 4. It's already there, we know we've done it correctly. Boron, atomic number is 5, therefore the number of protons is 5. Now, knowing that an atom has no charge, therefore the number of protons are equal to or are the same as the number of electrons, this column can be repeated into the electrons column. For carbon, our example, there are 6 protons, 6 electrons. Helium is neutral. 2 protons must mean 2 electrons. Lithium, neutral in this case, in this situation. Lithium, 3 protons must be the same as 3 electrons. Beryllium has 4 protons, must have 4 electrons. Boron, 5 protons, must have 5 electrons. All this is just copying from a periodic table. This column is where we need to know the mass number and the atomic number, and we need to know how to find the number of neutrons. I've already said that the number of protons and the number of neutrons here is the mass number, and in this case, the atomic number is the number of protons. So if we take away the number of protons from the number of protons plus neutrons, you're effectively taking that out of that, which leaves us with the neutrons. Okay, it's like saying I've got a bowl of bananas and oranges, and I've got another bowl of oranges. There's the same number of oranges in each bowl. How many bananas are left? We'll take out all the oranges. Okay, take out the same number of oranges from the individual bowl as the mixed bowl. You'd be left with the number of bananas. Okay, so in this case, helium, let's do a sum. 4 minus 2 gives us 2. Lithium, 7 minus 3 gives us 4. There are 4 neutrons. Beryllium, 9 minus 4 gives us 5. And let's double check with this one just to make sure we're on the right track with the same sums with this. 11 minus 5 equals 6. It's correct. We know we've done it properly. Okay, so that is your table done. As you can see, if you understand what the atomic number is and what information it gives us, as you're asked to describe in daily task number 4, as well as the mass number and the information that gives us, it allows us to complete all this table really neatly. And again, you need to have your periodic table and understand how to calculate based on an atom having no charge using those atomic number and mass numbers. Okay, good. Have a go.